Hi everyone, this is going to be a video on how to debug your DSO. We're going to be taking you through various important signals and showing you what you should expect on your own boards. The first thing we're going to go through is the power supply rails. These are important and you'll need to check them first because without this nothing else will work. The first thing you're going to want to check is the USB power supply rail. You should get around 5 volts on this rail. The next thing you're going to want to check are the +5 and -5 outputs. You will have large test points on your boards that show these. Next, you're going to want to check the 3.3 volt signal. This comes from the DC regulator and you have a small test point on your board to check this. Okay, so now we're going to go through the front end of the DSO. This is the signal path from the input all the way up to the ADC. The first thing I'm going to show you is the input protection circuit. So you can see that we're giving it a 5 volt amplitude signal and we're getting a 5 volt amplitude output. And if we were to increase the amplitude of the input signal, it clamps at 5.6 volts as expected. So the next point is the impedance network. And you can see this scales the signal down. After this, the signal goes to a buffer. And this does not alter the signal in any way. After this, it goes to an anti-aliasing filter. As this signal is only 100 kilohertz, the anti-aliasing filter does not scale it down at all. After this, it goes to a level shifting circuit. This level shifting circuit brings it into the range that the ADC can read. After that, the signal goes into the ADC and becomes digital data. That's the end of the front end. The next thing we're going to be going through is the trigger circuit. The first thing you're going to want to check on this is the output voltage of the DAC. In the GUI, when you change the trigger level, you should see the voltage from the DAC increasing and decreasing. Next, you want to check the output from the comparator. You should see a square wave on the oscilloscope, and when you change the DAC level, the duty cycle of the square wave should increase and decrease. So the next thing we want to cover is the PLL. If the microcontroller has been properly programmed, you should see a 5 megahertz square wave coming out of the clock pin on the microcontroller. If you don't see 5 megahertz, then you need to check your fuse settings on the microprocessor. This 5 megahertz signal from the microprocessor goes into the PLL, which multiplies it up to the clock for sampling in your oscilloscope. In the GUI, you can change the multiplication rate of the PLL, and you should see different clock speeds. After the PLL, this clock signal goes into the CPLD. If your CPLD has been properly flashed, you should see the same clock output on the fast clock pin. Now we're going to check one of the control lines to make sure that everything is working. When you click Capture on the GUI, you should see a single pulse on the enable pin of the microcontroller. If you don't see this, you're most likely going to want to check the UART to make sure that your computer can communicate with the microcontroller. To check the UART, put the oscilloscope probe on the TX line and click the capture button. You should see a pulse similar to this, which signals the computer talking to the microcontroller. When you check the RX pin on the computer side and click the capture button, you should see a stream of data representing the captures being sent from the oscilloscope back to the computer. Hopefully this guide helped you in debugging your DSO. If you have any questions, speak to your demonstrator, and thank you for watching.